Simon MB Electronics game. 1978, not working, spares and repair. And the seller's description was, please note this item is not working. Would be good for someone looking for spares or looking to repair. Battery compartment has rust and corrosion inside. Includes original instruction manual. Please see pictures for condition. Right, so let's go straight to the part which it says we have battery compartment rust. You can see that battery connector there is completely corroded, completely gunked up. The one on this side looks pretty good. We've just got a 9-volt battery connector in there. See what we've got. Ooh, that's interesting. Look at that. Okay, let's have a look at this first. So we've got one spring loaded on each corner, and they press down on these here. We've got a conventional, look at that, light bulb, love that, for each of the units, for each of the colour segments, and there's another bulb down here as well. On these switches, again they've got the same spring arrangement pressing down on this. But obviously you can see straight away where the battery's leaked. It's actually eaten through the bit of cardboard here. There's contamination on the screw here, over the bulb. It extends on this side of the board to the switch here, and also there's a build up on these pins of this chip down here. So this area here is contaminated. The rest of it, it looks in pretty good condition. Right, the bulb's out, 2.5 volts. I'm going to see if the bulb survived first. Excellent. I'll retain that bulb and put it aside. I wonder what horrors are under here. Let's have a look. Oh dear. Right, we've got a lot of damage here on these tracks. Part of the whole board has been destroyed. And that was the battery contact underneath there. So this isn't just a cleaning up job, this is going to be a quite a serious rebuild, and that's going to have to be done before I'm willing to put any power on it. Okay, let's move the electronics aside. Right, that's the inside battery compartment pretty much done. Put that to one side now. Have a look at the circuit board. My main concern really is this build up on the chip itself. How much damage has been caused to that? As this diode was right near the contamination, I'm just going to give that a little electrical test just to make sure that switch and diode is still working. Okay, that should conduct. 0.626 volts, and this side shouldn't conduct. Correct. Okay, so that diode is fine. Trying to lift this gently off the board, this contamination at the moment. Might have to give this area a scrape with a knife because there's a whole build up here that isn't coming off. It's obvious now that the tracks have been completely eaten away by the leakage. There isn't any track left there now. Okay, I just wanted to check that the tracks that have now been removed here, that there's no bridging between the three tracks that are damaged. There's no connection still between them. So what I'm going to do is I'm going to measure between that point on the meter on ohms and that bulb's there, which is open, and from there to there, which is open as well. So there's no join across those tracks there. The other three tracks are here and they go up to the chip. I've exposed a bit of the copper work down here so I can get on the copper. So that's between adjacent tracks. That's open circuit, and between that track and that track, which is open circuit as well. So I've got no bridging going on down here either. Right, the first track I want to bridge is this one here, so that comes around up here onto that connection there. So I'm going to solder a wire onto there. Okay, that's all of them bridged. So let's test it. This chip is actually a Texas Instruments chip. It's a 4-bit shift register, and the three cables, the three tracks we replaced with a wire now, are on these pins, so 4, 6 and 13, and they relate to the lights L4, L3, that's L1 and L2. So we want to check, in this particular case, pin 6, pin 4, pin 13 from the chip to the lamp, just to make sure that's working. So what I've done is I've hooked up the power supply, the bench power supply now, set it for 2.4 volts. I've connected the positive onto the positive rail of the board, because these lamps are supplied with positive all the time, and the switch, the chip itself switches the 0 volt negative. So what I should be able to do is connect on each one of these to make sure they work. So the first one was number 4, so starting from the top corner, 1, 2, 3, 4, and that should light that light there. There we go. So that chip is now connected to that. And then pin 6 is L2, which is this lamp. So 1, 2, 3, 4, 5, 6. That's that one. So that's working. And finally pin 13 is L3. So we've got 16, 15, 14, 13. That one there. So the cabling we've just put in is working correctly, and there's no shorts between them, i.e. when I put it on pin 13 it doesn't light 2 lamps or anything like that. So I'm happy with that. I think we're now in a position where we can put the 9 volt as well as the 3 volt supply onto the board and give it a try. Let's press the start button, see if anything happens. Oh, something happened. Right, let's press that one. Okay, all the switches work, all the lamps work, this all seems to work. So electrically it looks like it's fine. I've just put the D-type cells in and worked out where the battery contact goes for the positive, the original one, and it does make it possible to install one of these on that side down there, because I need the spring attachment on the negative of the battery. So what I'm going to do is I'm going to mount that inside in the correct position and connect a cable from here out to the circuit board directly. Okay, so that's the cable soldered on and it fits nicely into the position I want it. So that concludes the repair. All we need to do now is do a function test. So that concludes this repair of this 1978 Simon MB Electronics game. Works really well now. Thank you for watching. See you again soon.